Good morning, everyone. I'm Id3 from Sri Venkateshwara College of Engineering, and I will give a small presentation on Id3 algorithm. So it is basically a decision tree algorithm. Let's look into what do you mean by a decision tree. Decision tree. It is a supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. It is a tree-structured classifier where internal nodes represents the features of a dataset, branches represent the decision rules, and each leaf node represents the outcome. In a decision tree, there are two nodes. That is, one is the decision node and other is leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branches. The decisions or the test are performed on the basis of features of the given dataset. It is called a decision tree because, similar to a tree, it starts with the root node, which expands on further branches and constructs a tree-like structure. We can simply tell that as a graphical representation for getting all the possible solutions to a problem based on a given conditions. So this is the introduction or what does a decision tree means. And one of the decision tree algorithm is the Id3 algorithm. Let's look into the Id3 algorithm. Introduction to Id3 algorithm. The Id3 algorithm is a decision tree algorithm that is used to classify the data based on a set of attributes. It is one of the most commonly used algorithms in machine learning. The Id3 algorithm is important because it allows us to make decisions based on data. By using the Id3 algorithm, we can create decision trees that help us understand complex data sets and make informed decisions. So Id3 algorithm, which means we are going to classify the data based on the set of attributes. For a problem, we are going to have the set of attributes as well as the target variable. In that, we are going to use this decision tree algorithm by classifying the data on the set of attributes. And we can tell this this Id3 algorithm is also most commonly used algorithms, and it allows us to make the decisions based on data, and we can create decision trees understanding complex data sets and make informed decisions. What is Id3 algorithm? Id3 algorithm is a decision tree algorithm that is used to classify data based on a set of attributes. Works by selecting the attribute that gives the most information gain, which is the difference between the entropy of the parent node and the weighted sum of the entropies of the child nodes. To illustrate how the Id3 algorithm works, let's consider an example. Suppose we have a data set of animals with attributes such as fur, eyes, and legs. We want to classify these animals as either mammals, birds, or fish. The Id3 algorithm would select the attribute that gives the most information gain, that is the fur, and use it to split the data into the subsets. This process is repeated until each subset contains only one class label. So you're going to calculate based on the information gain, and this information gain is nothing but the entropy of the parent node and the weighted sum of the entropies of the child nodes. So from this we can get the subset, we can repeat and we can split the data into the subset, and the procedure will be repeated until each subset contains only one class label. How does Id3 algorithm work? So the Id3 algorithm works by selecting the attribute that gives the most information gain. Information gain is the measure of how much entropy is reduced by splitting the data on a particular attribute. The attribute with the highest information gain is selected as the splitting criterion. Once an attribute has been selected, the data is split into subsets based on the possible values of the attribute. This process is repeated recursively for each subset until all the instances in a subset belong to the same class or no more attributes are left. So it will be repeated recursively until it belongs to same class or no attributes are left. Let's take an example here. Step 1 is to calculate the entropy of the target variable. Here, place the target variable, whereas outlook, temperature, humidity, windy are the attributes. And entropy measures the impurity in a set of examples, and it is given by the table. So it has some of the instances with sunny, overcast, rainy, and temperature with hot, mild, and cool, and humidity with high, normal, and windy with yes or no. And the target variable, it is going to have two values, that is S or no. And the entropy, it is given by entropy of S is equal to P of S into log 2 of P of yes minus P of no into log 2 P of no. So where P of S is the proportion of positive examples, that is yes, and P of no is the proportion of negative examples, that is no, in the data set. In our example, we have 9 positive examples, that is the target variable which is equal to yes, and 5 negative examples with the target variable play which is equal to no, and thus the entropy is given by 9 by 14 and log 2 9 by 14 minus 5 by 14 into log 2 into 5 by 14, which gives the approximate value, that is 0.94. And we move to the second step, that is step 2. Calculate the information gain for each feature. Information gain represents the reduction in the entropy which is achieved by partitioning the data based on a particular feature. It is given by, the formula is given by gain of S comma A is equal to entropy of S minus summation of that SV mod SV by mod S into entropy of SV, where A is a feature, SV represents a subset of examples, and takes a particular value. SV is the size of the subset of SV, and mod S is the size of the whole set ES. For our example, we calculate the information gain for each feature, that is outlook, temperature, humidity, windy, by partitioning the data accordingly. We're going to consider it for outlook, and outlook with the features such as sunny, overcast, and rainy. And you're going to see how many times it has been repeated according to the target variable. And we're going to calculate each of these target, each of this feature, that is sunny, overcast, rainy, the entropy values, that is 0.97, 0, and 1. And finally, you're going to calculate the gain for the outlook, and it is given by gain of S comma outlook, which is equal to entropy of S minus 5 by 14 into entropy of sunny plus 4 by 14 into entropy of overcast plus 5 by 14 into entropy of rainy. So therefore, the gain of this outlook is given by 0.25. Similarly, you have to calculate it for temperature and humidity and rainy, so attributes of the problem. So the gain will become 0.03 for temperature and humidity. Similarly, you have to calculate all these. And windy also, it is going to become 0.05. And the step 3 is that select the feature with the highest information gain as the root of the decision tree. In this case, outlook has the highest information gain, that is 0.25. Partition the data based on the selected feature and create child nodes accordingly. Repeat the process recursively for each child node until the tree is complete or the stopping criteria are met. And we can look at some of the disadvantages of the decision tree is that it is simple and easy to understand the algorithm. that can be applied to a whole range of problems. I mean, to a wide range of problems. Then Second, it is computationally efficient and can handle large data sets with many attributes. Finally, it produces decision trees that are easy to interpret and explain to others. For example, the ID3 algorithm has been used in medical diagnosis to predict the likelihood of heart disease based on the patient attributes such as age, weight, and blood pressure. It has also been used in marketing to classify the customers based on their buying behavior and preferences. And we can see here that in this example, the first decision tree of the outlook, and it is going to look like this with the three branches, that is sunny, overcast, and rainy. And the subset of each of the data of this each branch is given for the sunny, and this is for the overcast and rainy. Thank you.